In this question, we are given two loudspeakers P and Q. They are arranged as shown below. They are supplied with the same electrical signal, so they emit the same wavelength and they are in phase. Describe and explain what an observer would hear as he moves from X to Y. As we have seen in the lesson, the two sources would form an interference pattern where constructive, destructive fringes would be formed. So as an observer moves from X to Y, he would observe a loud and a quiet, a loud and a quiet, and a loud, quiet series of points where he passes through constructive, destructive fringes respectively. Part B, describe the changes, if any, that the observer would notice if the speakers are moved closer together. The distance between the two speakers is given as d. So the question gives us smaller d. If you look at the formula, a smaller d would result in larger fringe separation. So these fringes would be further away from each other. Since wavelength is not changing, the distance to the screen is not changing, the effect of decreasing d would increase s. This is a mathematical way to look at it. The quick way to look at it, I can show you a hand gesture to picture this in your head immediately. Put your hands on your desk. Your wrists represent the two sources, and you're going to do this. When you move your hands together, you're going to open your hands wider. This is going to help you picture the interference pattern. So when the sources are further away, the lines make a smaller angle with each other. When they move your wrists together, open your hands wider, and you see what happens to the interference pattern. So that might help you get the answer quickly. If the frequency of the sound is increased, that means wavelength is decreased. So again, if you look at the formula, decreasing wavelength without changing any of this would decrease the fringe separation. So a higher frequency of sound would mean the loud points would get closer to each other. The speakers are moved further away from the line XY. In this case, the question is increasing D. So without changing these two, increasing D would mean an increasing S. So this would be the completed question. In this question, we're given a double slit arrangement. The wavelength is 640 nanometers. The slit separation is 0.85 millimeters. The distance from the sources to the screen is 2.4 meters. And we first need to answer what is meant by coherent light. Coherent light means the two sources have a constant phase relationship. This means this may mean that they are in phase, or it can also mean they have a constant phase difference. In our case, they are in phase. Explain how an interference pattern is formed on the screen. This is a 3-mark question. How an interference pattern is formed can be explained first by saying that the two slits act as two sources and emitting two waves. Those two waves meet in the medium. Where they meet with path difference n lambda, that causes constructive interference or a bright point. Where there is a path difference of n plus half lambda, that's where a destructive interference is formed or a dark spot. Part B is a calculation of the separation of the fringes in the interference pattern on the screen. Here we're asked to find S. So substitution into our formula gives our answer. That's the wavelength in meters. That's the capital D distance to the screen. And that's the separation of the two slits in meters. When you calculate, you get that. In part C, we're told that the interference pattern in B consists of a series of alternate light and dark fringes. The intensity of the light from one slit is now reduced. Suggest the effect on the appearance of the fringes. So, constructive interference points are where the two waves of same amplitude initially, when they meet constructively, the amplitude would be doubled. When they meet destructively, since the two waves have the same amplitude, the resulting amplitude would be 0. If you reduce the amplitude of one of these, if this is less, basically their sum would be less. So you can say the bright fringes will be less bright. When we consider the initially dark fringes though, without changing the intensity of one source and reducing the intensity of the second source, they will no longer add up to 0. They will now add up to a non-zero intensity. So we can say that the dark fringes will get some brightness. The first multiple choice question gives us monochromatic light. This means single color. We are told that the fringe separation on the screen is Y. So we can use this formula for Y. The distance from the slits to the screen and the separation of the slits are both doubled. So in this formula, wavelength is unchanged. The distance to the screen is doubled. So we can write the new Y as wavelength, which is unchanged. The separation to the screen is doubled. And the separation of the slits is doubled. These ratios cancel, and we still get the same Y, so it's unchanged. Answer is B. The next multiple choice question from November 18 gives us a diagram, and we know the fringe separation is calculated by this. Initially, red light is used. The distance to the screen is given as S, and the separation of the sources is given as D. Question is asking which of these statements below would cause a decrease in Y. Now looking at this relationship, increasing X, since it's directly proportional with Y, would also increase Y, so this is not our answer. Increasing D, since it is inversely proportional, yes, increasing D would decrease Y. Using green instead of red, well, green has smaller wavelength than red, so this gives a smaller wavelength. So decreasing wavelength would also decrease Y. So statements 2 and 3 will cause the Y to decrease. So the answer is C. The next multiple choice question gives us values to calculate really its substitution into the formula. We are given that wavelength is 480 nanometers. We have to write everything in meters. The distance to the screen is 2 meters, and the separation of the sources is 1 millimeter. When you write everything in meters here, remember in multiple choice questions you can't use calculators, so you need to do some rearranging. 480 times 2 would be 960. Adjusting the powers of 10 would have 10 to the power of minus 6. Looking at the options, the one that's equivalent to that is given in B. And The last multiple choice question gives us a diagram, which we actually saw in the lesson video. So we're given 4 options, and the question is asking which is the choice that corresponds to one fringe width. So we're looking for which one is Y. Well, if you look at D, this is 2Y. Y would be from here to here or here to here, so D would be equivalent to 2Y. That's not the answer. B is half of it, from one destructive to next destructive, or from one constructive to the next constructive would be 1Y. B is half of that. A, given in the diagram, is just a label of 2 wavelengths of distance. C is actually from one destructive to the next destructive. That's why C is our answer.